In this tried exercise, we're asked to graph the function f of x equals x squared plus 2x minus 8 using its properties. With a quadratic, what it means by its properties are, is it up or down according to the leading coefficient? Is the leading coefficient positive or negative? And then the x-intercept, y-intercept, the axis of symmetry, the vertex, and depending on how many points that gives us, if there aren't any x-intercepts, we might want to do more, but 1 or 2 points that we would plot along with that to just fill in the blanks as far as where the curve is concerned. So we'll start with our x-intercept. And again, remember the x-intercept is when y equals 0. So we'll start with the x-intercept, y equals 0. So x squared plus 2x minus 8 equals 0. So will that factor? Are there any two numbers that multiply to negative 8 that add to 2? There are. We actually looked at this in an earlier exercise. This will factor to x minus 2 times x plus 4 equals 0, which gives us x equals 2 and x equals negative 4, which gives us the x-intercepts of negative 4, 0, and 2, 0. So we'll go ahead and graph those. So negative 4, 0. Let's go ahead and we're going to make each one of these points. Let's see how far down we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We should be okay, so we'll just go ahead and stay with a scale of each unit, each grid mark being 1 unit. So we'll graph our negative 4, 0, negative 1, negative 2, negative 3, negative 4, 0, and 2, 0. So now let's look at our y-intercepts, or y-intercept since it's an up and down parabola. We also know that it's going to open up because our leading coefficient is just 1. A equals 1 in the form ax squared plus bx plus c. So the y-intercept is when x equals 0. So f of 0, well, that's just 0 squared plus 2 times 0, which is just 0, minus 8, which is going to be negative 8. So our y-intercept is going to be 0, negative 8. So 0, and then 1, 2, 3, 4, 5, 6, 7, 8 down. So there's our y-intercept. Now let's look at our axis of symmetry. So remember, that's x equals negative b over 2a, so that equals negative 2 over 2 times 1, which equals negative 2 over 2, which equals negative 1. So our axis of symmetry is x equals negative 1. So we could go ahead if we wanted to. There's an invisible axis of symmetry here. That also automatically gives us the other point at x equals negative 2. It's going to be negative 8 as well. And the reason for that is because that's the axis of symmetry. If you'll notice, the x-intercepts are evenly split as well from that axis of symmetry. 3 units each from that axis of symmetry. And then we'll go ahead and find our vertex. That's at the x value of the axis of symmetry. So x equals negative 1. So if we find f of negative 1, that gives us negative 1 squared plus 2 times negative 1 minus 8, which that equals 1 minus 2 minus 8, which equals negative 9. So that means that our vertex is at negative 1, negative 9. We'll go ahead and plot that point as well. And then we can always plot a couple more points if we needed to. I think we have enough here since there's two x-intercepts. And we got the 1 point from the axis of symmetry, from the y-intercept, the same direction, or the same distance, the opposite direction from the axis of symmetry. Let's go ahead and let's just look at two more points. What about if x equals 1, 2, 3? So at x equals 3, f of 3 equals 3 squared plus 2 times 3 minus 8. That equals 9 plus 6 is 15 minus 8 is 7. So that gives us the point 3, 7. We'll go ahead and plot that point. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 up. 3 over, 7 up. Now we have a couple options here. We could use our axis of symmetry. If we look at a y value of 7, that point that we just found is 1, 2, 3, 4 from the axis of symmetry. So if we go 4 the other direction, 1, 2, 3, 4, we know we're also going to have a point at, if you look at this, -1, -2, -3, -4, -5, -5, 7, because that's the same distance from the axis of symmetry. And if we put in -5, we'd get, what, 25 minus 10, which is 15 minus 8, which is 7. So it would verify if we found f of -5. This is just easier because we have that axis of symmetry. So we'll go ahead and connect our dots to give us our parabola. And there is the graph of the function f of x equals x squared plus 2x minus 8 using its properties. And again, for a parabola, for a quadratic, that means x-intercepts, y-intercepts, or x-intercepts and y-intercept if they exist, axis of symmetry, vertex, and then possibly a couple other points. And it's, as you noticed, a lot easier to use symmetry than it is to use algebra, but either of them will work fine.